I'm Nathaniel, and today we will now do question 5. But before we do that, I'm gonna tell you that in the middle of this question, we are gonna have a field trip. And you know where that field trip is? Yup, Desmos. We are going to graph lots of graphs in here, and trust me, just graphing the graphs in Desmos will be much better and more visual for you than just me talking about the question. Anyway, the only algebraic manipulation we're going to do is show that these curves meet when 2 cos squared theta blah blah blah. So, first we equate the 2 curves together, and then you get a plus 2 cos theta equals to 2 plus 2 cos squared theta minus 1. And then you have 1 here. And then you have 2 cos squared theta minus 2 cos theta plus 1 minus a equals to 0. There! We're done with the algebraic manipulation. Now let's pop over the Desmos and see what nice things come out. Okay, so we have the graph drawn in on Desmos, as you can see here. So we have 2 cos squared x minus 2 cos x plus 1. And then the minus a is up to your imagination. Just translate it. And it turns out that a is where the stationary points are. Let's see where they are. They are at 0.5, 1, and 5. There, we just solved our question. Sketch the curves. Well, as a matter of fact, Desmos has already, well actually I have actually sketched them out for you, and r equals to half plus 2 cos theta. Great, so how are we gonna solve this? Should these curves meet when this? So now we look at half now. It says that our intersection point is at theta equals to pi over 3. We can just substitute pi over 3 into any old equation, and then you will get cos theta will be pi over 3, and then it turns out that our radius is 3 halves. So r is 3 halves pi over 3. So let's look at 1 now. And just like that, we have solved part 2. Now sketch the points at where all the curves touch. As you can see here, this curve is actually called a cardioid because, well, it looks like a heart. And what more would you expect from a lovely cardioid? Anyways, you can see here, they touch at 3, 0, obviously, because the Cartesian coordinate is the same as the x coordinate, and the polar coordinate is 0 because, well, it's on the x-axis. And let's look at 5. Now, this is another cardioid. Well, by the way, this is another cardioid as well. Now, this is another cardioid, except that it is outside the curve. And now looking here, it's at -3. The radius is at -3, and the argument is pi, because if you go all the way down here, this is exactly half of a turn from here. This is why this is pi. And then we are done. We are done with the whole question. Ain't that quick? Well, see you in another step video.